What I want to talk about is what this means again. Again, when we're dealing with function notation, you have f of x and g of x, f of x, h of x, j of x. Basically, just remember, f of x is synonymous with saying y equals. It's just saying that there's just two equations. That's all. So what happens here, I'm going to kind of start off with this in real simplistic terms. Let's say we have two equations. F of x is 2x minus 1, and g of x is x plus 4. All right. Now, if I said, what is g of 8? What would you do?
Minus 1. Oh no, that's g. That's g. We're looking at g.
Exactly. The letter in front tells you what equation to work with. This says work with the g equation. The value inside the parentheses says substitute this into x.
Wait, so f and g are the same thing?
They're both just functions is what they are. Okay? They're two different equations just called different names. Okay, remember, f of x and g of x are synonymous with y equals. Instead of saying y sub 1 equals 2x minus 2, y sub 2 equals x plus 4, that means the same thing. So from here, I would just substitute in, and I would get 8 plus 4, otherwise known as 12. Yes, sir?
Is this how easy they're going to be?
Well, what's going to happen today, instead of this direct substitution like this that you guys have seen, we're going to do combinations of the equations and composites of the equations. In other words, it's going to look like this. What is f of x plus g of x?
Oh.
It's going to ask you, what is f of x plus g of x? Well, what is the f of x equation? 2x minus 1. So this would equal 2x minus 1. And what's the g of x equation?
X plus 12.
And what does that equal?
Didn't we just solve for 12? G, so it shouldn't be 12.
No. That was g of 8. So what do you get? You get 3x plus 3.
Combine like.
And that's what this is. These style problems turn out to be just nothing more than combined like terms. The only curveball that throws into here is that you might have to deal with some exponents. So you have to deal with the exponent rules. Okay?
Do you ever have to like multiply?
Yes. Okay. So for example, we'll use the same f of x and g of x idea here. Let's say I wanted to figure out what, and this is where the newness of this comes. I'm going to do what's called a composite. F of g of x. Remember, your f of x is 2x minus 1, and your g of x was x plus 4. Your first letter here, it says use the f equation, and everywhere in the f equation, I'm going to put whatever is in this parentheses. So my f equation was, what was it, 2x minus 1. My g of x equation was the x plus 4. So now I take this and I substitute in for x. And I get 2x plus 4 minus 1. Whatever's in the innermost parentheses of your function notation is what's substituted into this letter's equation.
Oh, so if we say that g of 8 is the function of g, can you say that? Yeah. So we just substitute.
That's why we put 8 in for x.
Yeah.
In this case, I'm saying instead of putting a number in for x, I'm putting a different equation in for x. I could say, what is f of car? And you would put in 2 times car minus 1 would be your answer. F of potato. 2 times potato minus 1 would be your answer.
Can you have 2 potatoes?
That would be 2 potatoes.
That's just match.
Why is it equal to
Man, that's messed up.
Because now at this point here, since the g of x equation was x plus 4, when I substitute in for x, I get this. So my final answer would be 2x plus 8 minus 1, which is 2x plus 7. That is the composite of both those equations put together. All right? What happens is you go through these things. As we start to work with some of the other style, we start to work with the different exponents. But once again, when you're dealing with addition and subtraction, it's all it is combining like terms, guys. So my two functions in this case are going to be f of x is 2x to the half. My g of x equation is negative 6x to the half.
Same.
So if I'm going to add those two equations together, f of x plus g of x, that means it's 2x to the 1/2 plus negative 6x to the 1/2. Okay.
What's the point is, why can't we just write 2 plus 1 over, or the 2 power, whatever it was, plus negative 6 plus 2, or not plus, it's whatever power, 1/2 power.
That's what we are doing.
No, but like, why do you have to write the x and g?
This is just showing, this is what it's going to say, this is the question they're going to give you with these two values here.
Oh, so
And
we're
you're
never-
going to answer it.
So we're never gonna see like an actual substitute or addition and subtraction problem?
This is.
Or I mean like it's not gonna be written out as
No.
a, so
It's going to be written like f of x plus g of x. And they're going to give you two equations. So what's 2 plus negative 6? And you're done. Richie.
I was just gonna ask, so the f of x, the x would be x to the 1/2. How would it be 2x to the 1/2?
Well, f of x is this whole equation here.
You can't divide that into
No. The only thing that's being raised to the half power is the x. The only thing in that equation being raised to the half power is x. Okay?
Where's the b? If you divide it by 2, it'd be half.
That's 1/2.
Oh.
Sorry. See, my handwriting is probably bad. What happens here, since I've got the same base with the same exponent, I can just add them together. It's combining like terms. It's the same thing as if you would have had 2x minus 6x. You get negative 4x. The only thing happens is that your exponents are fractions. No big deal. They stay the same. You didn't have to multiply. You didn't have to do anything.
Good thing they were the same.
You wouldn't add them?
No. Did you add them before? If it was 2x plus 6x, did you add your exponents there?
Only add
If you're multiplying. Okay? Those rules still hold true. It just so happens to be a fraction there. That's all. These never change. Yeah.
How does this apply to real life?
What happens is when you start looking at more of the composite style problems that you're going to see in the word problems, they talk about formulas and you can mix formulas together. And that's how this stuff works out. Also, you're going to see this all over the ACT. Composite of functions is all over the ACT. Okay? It's all over it. Same idea with subtraction. 2x to the 1/2 minus negative 6x to the 1/2. What changes when you're multiplying and dividing? Nothing.
Probably nothing.
All you have to worry about now is, again, worrying about your rules of your exponents. So when we're working with multiplying and dividing, it's the same basic principle. You're given two equations. You're given two equations to start with. You have your f of x is 3x. Your g of x is x to the 1/4. And then if it asks you to multiply the two of them together by saying, what is f of x times g of x? Well, you write them both out. 3x times x to the 1/4. Are those the same bases? X, right? Because if you take care of your numbers first, in this case, you're going to get 3 times 1. You get 3. When you look at your variables, are they the same base? They both have x, correct?
Yes.
Okay. What's the exponent of the first one? 1. What's the exponent of the other? When you had the same base and you're multiplying, what do you do to your exponents? Add them. What's 1 plus 1/4? 5/4. Very good. So you get 3x to the 5/4. Those rules haven't changed. They haven't changed from when you guys were doing stuff that was 3x times x to the 4th. You would get 3x to the 5th. The only thing that's weird is that it's a fraction. The rules are the same. Okay? The rules are identical to what we've been looking at. When you divide, you still use the same basic idea. You have f of x over g of x. When you write that out, you get 3x over x to the 4th. Again, when you work with your numbers first, you just get 3 over something. Who wins in the game of war? 1 or a 1/4? 1. When that happens, you just subtract the 2 exponents. What's 1 minus a 4th? 3/4. Since the 1 was greater in the numerator, the 3/4 goes up top. And you don't have to put anything in your denominator because it's over 1. Same exact principles and properties that we have worked with when you had integer values for exponents. None of that changed. The only thing that looks a little bit different is that you have a fraction that you have to ask yourself about. Okay? It's the only thing that changes up. Same thing's going to happen when we throw in a negative exponent. You're still going to work the same way. Especially when you're dealing with the composition. This is your f of g of x, the first example that I showed you. What happens here, we'll walk through all 3 of those slides. When I want to find the composite of these guys, I'm looking to figure out, well, I'm given by 2 equations. 3x to the negative 1, and g of x is 2x minus 1.
It's not very happy over there, is it?
So remember, when you're doing composite stuff, you start with the outermost letter. The letter is F. The innermost stuff is saying take that and put it into the outermost. So the inner one is the g of x equation. It's saying take this equation and substitute into that value of x. The exponent and everything stays the same. You're going to get 3, 2x minus 1 to the negative 1.
Is that all you have to do or do you have
Well, let me ask you this. Is that happy?
Not
What's not happy?
negative.
All of it or just the 2x minus 1? Just the 2x minus 1 isn't happy. Because that's being held within the parentheses. So since that's not happy, send them where it's happy. Yeah. Go to your happy place. Now, in this example, I don't need to continue putting my parentheses there because it's to the first power, so I can just alleviate that. Let's say if it was to the negative 2, you could have left it as, something over 2 like that if you had to. It's no big deal. Okay. But since it's just a negative 1 power, you can just rewrite it like that. Done. That's all you have to do. That's all it is. Again, when I want to go the other direction. Yes, ma'am.
So in that one, the negative 1 only applies to what's in the parentheses?
Yes.
So only that has to move down?
Correct, because what is the negative 1 implied to the negative 1 power in the f equation?
Just to x?
Just the x. Same idea here. If it's 3x squared, what's squared?
3x. X.
What's squared there?
X?
Just x. Now what's squared?
Oh, 3x.
That's the difference.
Oh,
Okay? Everybody see that? That's a very common question. When you think back to the old stuff, what's squared? Just the x. What's squared? All of it. What has the negative 1 power? Now what has the negative 1 power? That's the difference. Remember, The exponent is only for the very last thing in the string, or what precedes it, I should say. Okay? It's only for what precedes it. G of f of x. Now I take the f of x equation, I substitute it where? Into the g. Yeah. So I start with the f of x equation, and I go here. So I get 2, 3x to the negative 1, minus 1. What's 2 times 3? 6. So you get 6x to the negative 1 minus 1.
Why didn't you just do what you did in the last one? So 2 over 3x minus 1.
What has the negative 1 power? Just the x. Watch the parentheses. And that's why I'm glad you guys keep asking that question. You've got to be careful about where the parentheses are. The only thing that has the negative 1 power here, again, is just the x value. So now when I get to this part, what's not happy? Just the x. So you get 6 over x minus 1.
Is that 5 over x?
Does the 1 have the common denominator?
1.
The only thing that had the negative 1 power is when it was 6 times the x in the negative 1. 1 did it? You see an x there?
What's the final answer?
Did it change if it was 6x minus 1, would it become 5x?
No.
So what changes here? I can't combine it, I just rewrite it.
Oh, but so can you write 6 over?
Because when you lose, so when you lose.
That's what I just did, 6 over x minus 1.
So that's the same as if you move it into
No, that would be something very different. What has the negative exponent here? The only thing that has a negative exponent is the x. What's the only thing that moves then? The x. Suggestion. I can see with you guys who are having a little bit more issue with this. When you have a negative exponent, put whatever has a negative exponent in parentheses. Maybe that'll help you out. Yeah.
So your final answer would be 6 over x minus 1?
Yes. Done. No negative exponents. You're done. There's your
It's
answer.
the same as the, I know that's more simplified, but that'd be like 6 minus 1 over x minus 1.
It is not. It is not.
Wow.
It is not.
But wouldn't negative 1 be like negative 1 over 1?
No. Well, it would be negative 1 over 1, correct. But that's not a common denominator. This would have to be.
Kind of like a mixed price.
Do you have another color?
It would have to look like that.
I don't.
I can't see it.
Don't worry. You don't have to do that.
F of x.
F of x.
So that's 3.
Our f of x equation, and I've written it this way a couple of times today, and people kind of help clean it up a little bit. It's 3x to the negative 1. All I did here was rewrote f of x twice. Okay? If I want to take the f of x, what I'm going to do is take the f of x equation and substitute into itself. So I take this and I substitute into there. So you wind up with 3 parentheses 3x to the negative 1 to the negative 1. Because the x value had the negative 1 power, and I substituted a whole bunch of junk into something that's going to have the negative 1 power. What's that?
When you do like a negative
Multiplying, do you add the powers?
Well, I'm not multiplying anything. I have power to power now. I have power to power, so I have to multiply. But I also have junk raised to a power, so I have to distribute. So I have to do both of them. I have to distribute the exponent as well as multiply.
Which one's first?
So is the x turned into 1 or no?
Here's what happens. You have the 3 out in front. I am distributing this negative exponent, so I have 3 to the negative 1. I distribute the negative exponent to the x to the negative 1. that is your power to power, so you have to multiply. What's negative 1 times negative 1?
And then it's 3x over 3.
No, it's just.
Yeah.
And then you get 3 over 3 times x, which is x. The reason that is because the only thing that's left that has a negative exponent is the 3. So that 1/3 isn't happy. You get 3 times 1/3 times x. And it simplifies itself out. Yes, sir?
I thought the x had the negative one.
It did. When you distribute, you have to use your power to power rule. When you use your power to power rule, you multiply your exponents.
Oh,
So negative 1 times negative 1 becomes positive 1. That's why that works.
You multiply, so if you separate the x to the negative 1 power, you multiply 3 by 3 and then 3 by x to the negative 1 power.
No, you gotta take care of the exponents before you distribute that 3. Yeah, you use order of ops, and it's just, the order of ops happens to have negative exponents. It's a little weird, okay? There's more than one way to set that style problem up. You could have switched everything around to start with if you wanted to. It just so happens that when you have power to power, it's a little bit nicer to distribute the stuff through, okay? You're gonna be using the same examples of these power rules and stuff like that that we did yesterday, that we did last chapter as well, in this,
Oh, homework.
okay? You will be pleasantly surprised that it's a little bit easier than what you did yesterday.
Bird told me we didn't have homework.
Well, they lied. Bless you.
It was actually a cardinal. Mr. Murphy, oh yeah, I saw you said inject leg.